Navigation question, non-right angled trig. A ship left port A and travelled 27 kilometres on a bearing of 040 degrees true to reach point B. Another ship left the same port and travelled 49 kilometres on a bearing of 100 degrees true to get to point C. So we're finding the angle between their two directions, how far apart they were when they stopped, and their bearings from each other at the end. Always start by drawing the situation. Always draw a compass rose where they started. So, a neat little compass rose at port A. Now when we're doing navigation questions, especially when it's non-right angled trig, you're best off keeping it as close to scale as possible. Keep the angles as close as you can to accurate. Use a protractor if you want. And keep the lengths as accurate as you can. Because if you get a misleading diagram, it's really going to mess you up. So 40 degrees for ship going towards point B, so sort of around there. And we want 27 kilometres. Then 100 degrees true, well this is 90 here, so 100 is actually going to be, sort of like this. And they're going further. That's 49 kilometres, so make sure that you get a really clear, there's more distance travelled there. And that's going to point C. Now the first one, I'm sorry, I haven't put my angles in. So we have 40 degrees in here, because that was 40 degrees true. This is 100 degrees true. So here we'll have 80 degrees. And my first question was just the angle between their directions. And this is 100. Take away that 40. So I've got 60 degrees in here. So 60 degrees for our first answer. How far apart were they when they stopped? We'll close our triangle. And that is distance A. If you wanted, if you're feeling uncomfortable with it, you could redraw just that triangle. But so question B, we're finding side A. I have two sides and the included angle that says I'm going to use the cosine rule. Choose the one that starts with A squared. Substitute our values. Whoops, running out of space. Type all that into your calculator, and that gives me A squared of 1807, because I cheated and did it before. Find the square root of 1807 to get side A. So 42.51 kilometres. So how far apart were they when they stopped? 42.51. So the question that often throws people is to find these bearings. The bearing of point B from point C and the bearing of point C from point B. So what matters is the from. And when you're tackling a bearings question and they ask for a bearing from somewhere, the first thing you have to do is put a compass rose at that point. Point B from point C, put a compass rose at point C, and draw in the bearing that you want. So the bearing that I want is facing from C up to B, which means it will be this angle around to there. Now you can't find that angle, but you can find it by finding other angles in the triangle. So we look for what we do know. The next big trick that we tend to miss out on is that the compass roses give us a pair of parallel lines, and the lines that join them give us alternate angles. So if I just wanted, this angle in here, that's alternate to the angle that was made by that line, so that's 100 degrees just in there. I know I've got 180 all the way around here, so the only angle I need to find is this one in there. So using that alternate pair of angles is really, really important. You could have used the 80 degrees on this side or the 100 degrees there. So we find this angle. So my next step is going to be finding angle C. If you needed to, you'd draw the triangle, but I've got a side and an opposite angle, and I want an angle and I've got an opposite side, so I can use the sine rule. Notice how I say what I'm doing each time to keep my working really organized. Sine of C, starting with what I want, over C, equals sine of A over A. Substitute your values in. Oops, no equals sign. Side C, 27. Sine of 60 degrees over side A, we found that, 42.51. Rearrange, inverse sine, take our 27 up to here, and solve that to get angle C. So angle C, 33 degrees. We'll go to the nearest whole number for this one. Now that isn't your bearing. That's 33 degrees in there. And by drawing the whole bearing that you need, you can really clearly see what you need. So that whole angle is 180 degrees, round to here, plus 100 degrees, plus 33 degrees. So what that's 100 plus 180 plus 33, that's 313 degrees. And so your bearing, and you'd write this down, word answer, the bearing of B from C is 313 degrees true. Now the bearing back the other way, there's a simple trick. You add or subtract 180 to reverse where you're going. So I was going from C to B. If I want to go from B to C, sorry, I'll move that so we can see it. The bearing of C from B, let's make that look like a C, is basically, if this is less than 180, you add 180. If it's more than 180, subtract 180, because it reverses the direction. Is 313 minus 180. That's 133 degrees true. So the steps you've got to follow rely on drawing an accurate diagram, drawing a compass rose where your bearing is from, drawing your bearing in so you can see what you're after, and using those alternate angles.